Hey there, welcome back to another video with the Math Doc. We are still talking about linear functions, and in this video I would like to highlight the difference between discrete and continuous domains and ranges for linear functions. As a reminder, the domain of a function is where we get the inputs from. And we often designate x as the name of the variable for our input, while the range is where our y's or our outputs come from or go into, whatever language you would like to use for the action of the function. So the interesting thing is that for a linear function, and really for any function, we can have a discrete domain or a continuous domain, and that will usually translate, if we have a discrete domain, we'll usually have a discrete range as well. So a domain and range can be discrete. If we have a continuous domain, the range can be either discrete or continuous. And we did see one of those examples in a previous video, and I'll remind you of that. So in order to understand the difference between discrete and continuous, we're just going to look at a couple of examples so that we can get an idea of what that is. So let's start with discrete, and in this example we're looking at the weight of coins. So say we have pennies. We'll say that the weight of a penny is, say, 2 grams. This is just a guess. So that would be the weight of 1 penny equals 2 grams. So now if we look at the function that is defined for the weight of multiple coins, the weight for, say, x coins would be just x times 2, right? That would be our weight. So this would be the weight. This would be the number of coins. And this is the weight for each coin. So if we want to draw this as a function, as the weight as a function of the number of coins, x. So if we have 0 coins, we'll have just 0 grams, right? If we have 1 coin, that'll be 2 grams right here. If we have 2 coins, we'll get 4 grams, and so on. Now the thing is that we can't really have half a coin or a quarter of a coin or a tenth of a coin. So in this case, our domain is given by the natural numbers, the 0, 1, 2, 3, so integers that are positive. So our domain in this case is natural numbers. And these are discrete, right? They are discrete because we can't have half of an integer as part of the natural numbers. We can't have a fraction of a coin. So this is an example where the domain is discrete. Now what happens to our range? Our range is also discrete. We actually have a range that consists of all the powers of 2, right? We have 0, 2, 4, for 3 pennies we'll have 6, and so on. So both our domain and our range are discrete. So that's a really simple example of a discrete range, domain and range for a linear function. Let's now look at the continuous side of things. And here's an example. We're looking at the distance traveled when we're going at a constant speed. So when we're traveling at a constant speed, and let's say our speed, I'll designate that by s, equals 65 miles per hour. Okay, that's a reasonable speed for a car on a freeway, and say we are traveling at that speed. We are neither accelerating or slowing down. So if we travel 1 hour, let's do a little table here. Time. Let's do and distance. So if we travel for a full hour, we travel 65 miles, right? Because we went a full hour at this speed. If we travel 2 hours, we will go a distance of 65 times 2, which is just 130. But we can also travel 1 minute, right? What if instead of an hour we travel 1 minute? 1 minute is a 60th of an hour, right? In that case, the distance we travel is 1/60th times 65, right? And so that would be 13/12 of a mile. So in this case, we can actually travel any fraction of an hour, right? I brought here the example of a minute. We could travel 30 minutes, which is half an hour, in which case we would be traveling 32.5 miles, right? But either way, whatever we do, our distance can be a fraction of 65 miles, and our time can be a fraction of an hour. So our domain is continuous. We can travel 0 to basically infinity hours and any fraction inside. And our range as well, we can go from 0 miles to an infinite number of miles. That assuming we have enough gas to travel like that. So now if we graph our distance here as a function of time. So again, when we're at 0, we haven't traveled any miles, right? We haven't passed any distance. But then if we travel 1 hour, let's write 65 right here. If we travel 1 full hour, we've traveled 65 miles. If we travel 2 hours, let's say that's 130. So we travel 130 miles, but we can also travel that much time or that much time. And so we really have let's draw this a little more accurately. We have a continuous function here in that our domain is continuous as well as our range. Now, I don't know if you remember, but in our one of our first examples, we looked at a function that was the cost of parking. And when we look at the cost of parking in a parking lot, let's change our color here to blue. So fee for parking, we assigned the fee as basically a jump in our in the cost, meaning every hour was $1. We said that we can park for a continuous amount of time. So our domain is continuous. However, our range, the fee or the payment, went in jumps of $1. We paid $1 for each hour or fraction of an hour. Now, this is you'll see momentarily when I draw this function, this is clearly not a linear function. However, it's a nice example for a sort of mixed domain range. So our range is discrete while our domain is continuous. So for the first hour or fraction of it, we pay $1. That's here. So our function is like that. For everything above 1 hour, but up to 2 hours, we pay $2. And the same goes for 3. We climb up to the third step. So this is not a linear function, although it can be approximated if we look at a very long time. It's not a linear function, it's just an example. The interesting thing is that for a linear function, the domain and range have to have similar characteristics. So for a linear function, if our domain is continuous, our range is also continuous. If our domain is discrete, our range has to be discrete. And that's one of the differences between a linear function and other types of function. So this was a quick sort of explanation of what the difference between discrete and continuous domain and range are. And if you haven't seen the other videos about functions and linear functions, take a look at the playlist. If this was a helpful video, please like, and all comments below are welcome. See you next time.